Okay, my good friends. It's Roger once again. I have Liam Martin with me, and we've been discussing a lot of different topics. And one of them, I decided I should discuss with Liam about what I just put up today on academia.edu, and it's a paper about my atomic research, and it's a new atomic model. It's called the dipole electron flood theory. Now, I'm asking for academic feedback, so let's click on this right now. You're invited academic feedback, and you click on here, and boom, here it is, discussion. All right, nobody's discussing.
Okay,
yeah. Now,
yeah, I'm on that side as well. Yeah.
Right. Now, here's what I put up. Dipole electron flood theory. It was, I've had this for years and years and years. I just dated it 6/1/2023. This is, I don't know, what is it, the 27th or something. But anyway, now, it's a new atomic model. It changes the nucleus from a completely positive into a dipole made of tiny dipoles called Dirac neutrinos instead of a large positive core. Does that make sense to you? They're dipoles instead of one big positive proton.
Yeah.
All right. The protons and neutrons are made of dipoles and in certain stable quantities, which are different atoms. So this is the periodic chart. All right, and as they get bigger and bigger and bigger, it's just more and more and more of these little tiny dipoles. And the smallest one is hydrogen. That's the smallest stable atom. Hydrogen, though, is not one proton and one electron. It is 1,824 or 1,825 dipoles. All right, you know what a dipole is a positive and a negative. It's just like a bar magnet. All right, so there's 1,825 of them, and they come out like a ball like this. And in the center, right, in the center, the dark matter goes to the center, and it's coated with all the white parts. They're not going to be all these different colors. They are going to actually turn into all these different colors, but the colors are in layers. The blue is right up tight against the black. The black is the core. The blue crushes right down tight. It's just glued right to it. That's why when you see blue light, that's the rocket ship light. Because to get it away from that black, you really got to pop it out of there. And when it goes flying out of there, it comes out like a rocket ship. And I'm going to show all of this. Now, this one ball would be a proton, and it would have 1,823 or so electrons, which, well, dipoles, the little bar magnets. And the black goes to the center, and the white part coats it. Now, the white part is the part where there's the energy. That's where the energy is. The black is where it sucks the white into it, and with absolute desperation. That white will go through anything, just like if you're standing on the street and lightning hits you, it will go through your body and explode everything in your body to get to ground, which is black. That's where the black matter is. The ground has a heavy excess of dark matter. That's why lightning, static, electricity, all of those particles, which are the white ones, right to ground. That's where they want to be, into ground.
Is that because of the mass? It's looking for that. It sees that mass. It's like, oh, I need that.
It wants to be paired up with the black particle. Let's take a look at some of the pictures, and that'll make more sense, I hope. But what I'm going to go do is, this paper goes right through every particle. It talks about how many numbers there are. It is 1,823 in a proton, and a neutron has equal numbers, so it's neutral. The proton wants to either give one up or take another one in to become neutral.
Yeah, like everything, yeah.
All right, so odd numbers are charged. Even numbers are neutral. All right. Now, the way the dipole nucleus is set up is the dark muon neutrino is the core, surrounded by the white electron neutrinos, just like an eggshell surrounds a black center. All right, now, I don't know this for a fact, but it does appear that they are equal numbers and they're opposite charges. Right now, they say a proton is one gigantic plus, huge, and then one electron, which they don't even account has any weight, is the same charge, but it's the opposite. How could that be? How could one be the size of an Empire State Building and another one is the size of a marble, but they both have the same charge? It's ridiculous.
Yeah, it can't be balanced, can it?
It has to be a dipole. I knew this when I first got out of the Army. I knew it probably when I was in the Army, but I knew for a fact I had this dipole theory that everything is made of dipoles. It has to be. You can't have a big positive core and a tiny little negative. It would suck right down on there, and it would never leave. I mean, it's ridiculous. So.
Exactly. And every layer of life is a dichotomy, right?
Yeah, it's everything they have is they just fluff it off. It's just like in space is saturated, absolutely saturated with particles, and they just treat it like there's nothing there. It's a vacuum. It's not a vacuum. Plus, I showed you all of those fields. Look at this. We're going to go over this stuff in a second, but look at this. What's in space? And they say the particles go flying through there, just don't hit anything. They're just banging into things like crazy. The things that they're saying are hundreds of zillions of miles away. They could be right down the street. I mean, they could be really, really, really close, basically. And
yeah, because as we discussed earlier, like you say, there's no way you can offset for it, and these distances are ludicrous. Right.
Yeah, they're just not right. Everything slows down. Look, here's what happens with light. Let me show you. All right. Consider this red wave.
Huh?
That wave is driven by a particle that has a magnetic field around it. So you've always heard of particle-wave duality.
Uh-huh.
That's it. The particle is back here somewhere, and the field surrounds it. So the field has to push every other particle's field away from it. You follow me? So
yeah, like a wake, or reverse wake.
Well, every other particle that's in the air, every molecule in the air, every gas has all these same electrons all over it. All these little white glowy particles that want to push somebody away from them. So in order for it to come through there, it has to push against them. That's where slows light down. It slows down. There's no question about it. And it slows down fast. In a non-vacuum, it slows down very fast. Here's light coming through the Venturi.
Yeah, I love that picture.
All right, and you can see it's concussing with everything in front of it. And this is where you have that little black stripe. Those are the things that don't get bigger or smaller. They're exactly the same size forever, and they push the white. And the white can glow when it's being pushed hard, or it can be very small when it's not being pushed hard.
Mm-hmm. Yeah, I get that. See, this picture, if you're into particle physics and you know what you're looking for, that, they say a picture paints 1,000 words.
Yeah, well, here it is right here. Here's the 1,000 words in one picture. Fermilab put out this picture right up here. And these are the smallest particles they've ever found. The black one is the fixed particle, never changes. The red one is the point particle. It can get big and get small. Now, this is directly from Fermilab. Now, here's what we did right here. There's the black one, and there's the point particle. You see one of them is bigger than the other one?
Yeah.
And this one has one attached to it, too. And if you could see, this down here is where the forward leading one is concussing with those little particles. Right, you see them?
Yeah. It just nerds me out to think that they don't know this, but then I think Maybe they do.
I've shown it to them. I went to the University of Geneva. I showed them all of this stuff. I said, here's what we did. Here's what we found. Here's how we did it. Here's what we used. Here's the results. It fits every single thing that you people are looking for. And they did not dispute it. They did not dispute it. And here it is right here. What they're looking for is fission and fusion. Here it is right here. You saw the particle.
Yeah.
You see the particle. They are fused together. Do you agree they are one particle fused as a group?
Yeah, and you managed to separate them.
This is fission. We broke them apart. When you have something stuck together and you break it into bits, that's what's called fission. The black particles are dark matter. They've never been seen before. And the reason is because dark matter is at the core of everything. Everything that bounces back at you is light. All right, so the only thing that bounces is light. The black does not emit, it does not absorb, and it does not reflect. And the only reason we can see it is because it's laying on top of the white matter, obstructing the white matter from coming at us. You see out here, over here?
Yeah.
And you see all the way around the edges how all that black matter is getting pulled into the white. The white this is what they call the strong nuclear force. The white wants so desperately to be attached to that black that it will run through a car's engine, a car's motor, and spin that motor a bazillion miles an hour to get to the ground, which is the black. Just like I mentioned to you, our Earth has to be saturated with this black matter. It has to have a high excess, or maybe not. Maybe it doesn't have to have a high excess. I don't know. But I can tell you what, the white particles want so desperately to be attached to the black ones that when light comes down through the Earth, it warms you up. It fuses into things. And when you get lightning and static and you have an accumulation of electricity, electrons, which is the white, it'll explode you. It'll force its way through anything to get to the Earth. Just like this white will force its way to get to these black particles.
Right.
If we could put a harvester right in between here, right in between. I'll show you what it is. Here's the way I envisioned this working. You could carry it around.
I think you're onto something. I don't think it's going to be that hard to collect it. I don't know how.
Well, I'll show you. No, I think it's very easy. I just don't have the ability to do this. Here we're seeing the light accelerating. When you see this luminosity, that means you have a ton of electron showers, which we created. We show you what their potentials are. And
that's what they're looking for, aren't they? And so they're trying to get that, aren't they?
All we want is the white. That's the only thing that has the energy to heat things up. All right, and I can absolutely prove that by the house burning from the white particles. You've seen that, right?
Yeah, I've seen that, dude. It says it all, and you can see it as well, can't you?
Yeah, I will do that just to prove it in a second. But let's talk about harvesting this light. The laser takes almost nothing. These lasers, I've been using them for years on 2 little AA batteries, and they still shoot out the same power. So how much electricity are we using to run the laser? Almost nothing. When it comes through that slit and we get those electron showers, we are getting unbelievable amounts of energy. Once you can separate the white from the black, it is so attractive to the black that they call them electron showers. I'll show you the physics behind it, because they just did a paper on it a couple of years ago. But these things are tiny. These little lasers are just as tiny. They're pin size, and you can have dozens and dozens and dozens of them inside of this little box here. And in that box, if you can see that little funnel looking thing, We're getting all of that radiation through there, which is just nothing more than the white particles, which is the only thing that you want. When you charge your batteries, that's all you're doing is putting the white part back in. You're not putting the black part in, you're putting the white part in. You follow me?
So that's where it's coming through the Venturi then. So your collector's got to be pretty close before they reassemble.
Exactly. So what we do is right where I'm showing my cursor now is about where we would put our harvester. Before it gets back to the black. Once it gets back to the black, it's just nothing more than particles again. There's no real good value to them. But before it gets back to the black, it wants that black so desperately that we can shoot it down through a conductive photodiode. And a photodiode means when we slap that black against it, and that's what we're doing, we're hitting it like a brick. Slam, slam, slam. You saw how hard it hit the house. That was the only reason the house went away, is because the black came. We're going to go over that in a minute. But what we are using is a pulse. Bam, 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 bam. And the white shoots through there like a squirt gun. And white has no mass to it. It will go wherever it's told to go. It'll just go flying through there. It's going to go down through that photodiode, and that photodiode is a gate. So it comes through the gate into our battery stack. It cannot get back. So we have harvested that white, and we can squirt that all day long. All day long.
You only need to siphon a tiny bit as well, wouldn't you?
Say that again?
A smidgen of it. So you wouldn't even need to siphon off that much, would you? If you just got a tiny bit of that.
You would think so, because here's the energy values. Here's what they talk about. This, remember, you see up here electron showers. All right, above it is the muon, the black ball. These are the black balls, and obviously the white is the electron shower. Now, there's physics involved in electron showers, and here's where they did the physics. They wanted to collect electrons by smashing protons together and knocking electrons off. You don't need to do that. It's ridiculous. So they want to do proton-proton collision, then they can produce hadrons, then they take the decaying hadrons, they create a flux, then they create the neutrinos, antineutrinos, then they get the electrons and muons, which we started with.
Yeah, that's like the equivalent of you've just got a mousetrap, and they've got the game mousetrap and set up a big obstacle course.
Yeah, they got the nuclear one on steroids. Now, so here we got energy of neutrinos. Now, I showed you a muon and electron neutrinos. That's what they are. And electron showers creates up to a few 100 billion electron volts, up to a few trillion electron volts. So that's what happens when you can get neutrinos. You can get that kind of energy. Now, I'm not claiming that it's a fact, but it looks to me that that's what we did. Well, I can tell you for 100%, no question whatsoever, that is fission, and this is fusion. And all you ever hear about is, we can do fusion, we can do fusion. Well, they want to take gigantic particles and add all the energy that they're going to get back. They have never broken even. Yeah. They push so much energy into it, and then they say, and now we're going to get all that energy back. Well, you look at all the energy you used.
Yeah, exactly.
We did nothing. We did nothing at all. We just shot the light into a crusher. Now, what they're doing is head on. What do you think that does? It crushes the fields. All they're doing is...
If you can get them to hit head on, which is going to be pretty damn hard.
It is hard.
So many, aren't you?
Well,
ravages.
Once they started focusing, they got a lot more to hit. But before, they were doing 100 billion particles, and they would only get 25 to hit. 100 billion. And they use a 6 mile ring. And they could only hit it like every now and then it would cost them, I don't know how many hundreds of thousands of dollars a shot to do this thing. It's absolutely insane. We did this, everything I did and everything I'm showing you, we did for less than $500.
I remember you saying that before, and the thing that's perplexing about the CERN thing as well is they're talking like they need a bigger one, a bigger one, a bigger one. It's like, no, you can't. You're on the...
Well, actually...
Keep making it bigger and bigger, can you?
Actually, they're changing that tune now. They've come down to doing what I did. They're watching it. And I've shown it to all of them. I had a big fight with Fermilab with this guy right here, Don Lincoln. He put this up here, and it was called "What's the Point?" They took that page down because I kept saying, he's saying I found his particles. They took the page down. Fermilab. That's a government agency.
Yeah.
They're spending billions and billions and billions of dollars a year for decades.
Yeah, because you made him look stupid.
That's the problem, and he knows it. And we really had it out, me and him. And it didn't end well.
That's the thing. It's like we hear this all the time. Science, credibility is everything. So, and I always say this: it's the only field of study where if you can prove you've been talking rubbish for 20 years, people will give you an award. But if somebody else does it, your career's over. So they can't afford for this to happen, because then it blows the door open. And what if people start asking questions about it and then asking for refunds?
Yeah, no. That's 100% correct. The only thing is, what you need to do, somebody should engage and become the hero and say, it's time to look at this, and then they can, once you take it into the academic realm, if a guy has got, like, I was hoping we could get one of these science communicator guys that they're not really scientists, they're celebrities. And they're on TV, Bill Guy and Mikio Kaku.
No, the paid off guy, don't talk to him.
Well, no, I couldn't care less if he's paid off or not. If he gets the word out and says, look at this guy, what an idiot he is. And I let him just call me an idiot. And then people will see this and say, that guy's not an idiot. Let's say you're the idiot.
The reason I say that, Roger, I'm not being facetious. The reason I say that is because he'll never debate you.
I know that.
He'll never do it.
I know that, but that's why. That's why I'm.
Go ahead, sorry.
Well, no, that's why I bring these things up, is to embarrass them into speaking.
Yeah, that's what you got to do. I think you're on. I know it's a hard run, and you've been doing it a long time, and you lose friends with doing things like that. And I know it's hard, but this is the only way it's going to get done. I think, it's not just my opinion, it's the only way it's going to get done. But you've got to embarrass them. It's like, for me, the mainstream media is dead, right? It's in its death throes and it don't know. The politicians are becoming irrelevant. Do you know what I'm saying? That it's these demonstrations and conditions behaviour, and we know it, and so eventually they become irrelevant. It's just a matter of time. Do you know what I'm saying? So they're going to have to jump on board, and look what they're doing now. They're starting to play towards what people, do you know what I mean? They're starting to switch it. They've got to, because they're going to become irrelevant.
Well, exactly. They're going to be seen as fraudulent.
This is why I've reached out to you, Roger, because I happen to know, just from an experience, that these people like you, these groups, they were gathering in the shadows, and on these free speech platforms, and eventually, once people get fed up with it, they're going to end. All the cool kids are going to be on these free speech platforms. You know what I'm saying? And we're going to be light years ahead of it. Well, no pun intended, but we're light years ahead of them. And we're doing it on nothing, on a shoestring, on nothing. And it reminds me of that's why I like America. People say a lot of bad things about America, but look how America was built. That's a bunch of randoms out of nothing with no base to work from. That was an amazing achievement. You know what I'm saying? It takes a bit of willpower and effort.
As long as we can get some people to pay attention to what is material evidence. I'm a material evidence person, and I showed you. Did I show these people the fields in space? I don't think I did. These are. All right, remember we were talking, Liam, about the particles coming through space, and right now the mainstream opinion of space is a vacuum, which is not a single person in the world can stand behind that statement. Secondly, even if it was a vacuum, everything that's out there has fields surrounding them, and those fields push against other fields, and every light particle that's streaming through there is a field. So we have field against field. So they're slowing down.
Yeah, and even if that wasn't the case, right? There's dust everywhere. There's anomalies. There's no way. It's not. It's the thing is that originally we said, oh, time, space. It's all a flat. It's not constant, is it? You know what I'm saying? There's fluctuations all over the place. There's no way to account for it.
We have no idea how slow light is coming at us. We know it's slowing down from every different direction we look at, so we think that we're the center of the universe, apparently, because we say everything is shifting away from us, and that's what pulls the light away, making it red. No, the light is slowing down. It's going bam, 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 and it's coming down slower and slower. I could show all of it. Well, I have shown it all. And I've shown the particles. Here they are right here. Let me show you the progression. Here's light coming through the air, pulse red laser. Boom, 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 boom. You will not even see these pulses, basically, in the air, except for the fact that it's getting ready now to start accelerating. This is the leading edge of the acceleration. Now it's going into full acceleration mode. All right? It's actually pulling the magnetic field forward with it, just like breaking the speed of sound. Only we're breaking the speed of light. And not only doing it, breaking the speed of light, we're in the atmosphere, which you can see is saturated with particles. So we are plowing through those in addition to speeding up. We're pushing those out of the way to speed up. So I could see if you said light can accelerate in a vacuum. Well, if there's nothing in the vacuum and you got a little extra kick to it, yeah. But light accelerating inside space, no. This is not right. This is way, way, way beyond what they could ever have anticipated. This is not acceptable. And it's not acceptable at all. No. So what happened to these light particles? You see that stream coming out of there?
Yep.
Those are the actual photons. Now, what are they here? They're not light yet. Here they're starting to become light. Here is when they bounce. The bounce normally is what you would call light. Now, back here they're neutrinos, which means they haven't gained enough energy to be light particles yet. But they are backing up on each other. You see, it's starting to get glowier and glowier. That's like a flavor of neutrino back here, which let's say has one mass. It's starting to bang up against itself. It's gaining energy. It's got 2 masses. It's got 3 masses. It's got 5 masses. It explodes into literal trillions of masses, trillions of energies. You know, it's actually not masses. Back here, they're energetic values. And neutrinos just keep getting more and more energetic. And here they are as they are actually traveling through the air. Here's the red ones. All right, you see back here, way over to the left?
Yeah.
You see the little white and the black on top and the black on the bottom?
Yeah.
That's a neutrino. It's not a photon yet. Then it goes sideways as it starts to back up on itself. And then it becomes the photon, which is the back-to-back black and white balls.
Right, yeah, I'm glad you just mentioned sideways as well, because I noticed in that last image it's almost like a flat plane.
Yeah, and then back here, way up here, right where it hits the venturi, they just go into craziness. But these are all particles. Now, this is what's coming out of that light source. That was red. Here's green. Hold on 1 second there. All right, so I'm back here. Now, here's the green particles. Identical particles, identical neutrinos. There is no difference, only they're very powerful. The green is much more powerful than the red. And the blue is like...
isn't that the hardest laser to make, a green laser?
No, the blue. I don't know if the blue is this one here is the killer. That one there.
Oh, yeah, because that's...
Yeah,
that's going to be really fast.
The blue is the one that really turns it on. Now, I could take the red laser and I can take the green laser and try to drive an LED backwards and create energy, and they won't create any energy. If I take the blue and drive the LED backwards, it creates energy. So these have extreme concussive values to drive off electrons. And I'm going to show you that in CERN's experiments, where they explode head-on collisions. And you're going to see the blue. I'll show you the things that they see. They don't even realize they see them. But I see them, and I know exactly what they are. Let's take a look at that, Liam. Hold on one second. All right, let's think about this carefully. We're looking at the green ones. I show you the red ones. There is no difference between the green and the red. Now, here's what they find at Fermilab and CERN. You see this? You see that? That's exactly the same particle. Now, they also see them broken apart with just a blue one and just a red one and just a green one, which is when they're broken into bits. Which we can do that too. We did that and created the muons and the electron showers. Now, what they're hitting though is protons. You see proton, neutron, the P and the N? That's what they're smashing together to create this zoo of bits and pieces. The only bits and pieces that make any difference whatsoever are these two bits and pieces right here, the black one and the other colored one. It can be black, it can be red or green or blue, and I think it can be almost any color. Although I'm not sure of that, but I do believe it can be any color. Because when you receive light back at you, you're getting an electron stimulating your eye that is a certain frequency, and that is a certain color. So, as far as I'm concerned, red, blue, and green are not the only colors. Although they are the ones we use in lasers, and they can create any color. And I believe they may be the three orbitals. The first one closest to the nucleus is the blue, the next one out is the green, and the furthest out one is the red. And the red doesn't go anywhere when you smash them. You want to see something? Watch this. This is CERN. This is when they hit their things head on. Now, stop and think about this now. I'm going to ask you a couple questions. Why do you think the red is like it is and all those other things are looking like they are? Why is it? Why is that?
The red seems all kind of messy, and then you've got... Okay, let me just think about this. Is it to do with the compression then? Because they're loose.
Here's the deal. All right, here's the deal. The nucleus is right here where I got my little cursor spinning around, right?
Yeah. Mm-hmm.
There's a black core there. Surrounding that is the blue, really glued tight. Outside of the blue is the green, not quite so tight. Outside of that is the red, really floppy. So when these things hit together, the red doesn't have enough energy of attraction to the core. It just sort of gets out of the way. You see what I'm saying? It's not glued to the core like the blue is and the white and all these other. You see how the yellow, the blue, the white, the pew, 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 they're taken off because they were really glued to that core. And the only way to get them out of there is to smash them head on and force them to flee from the black matter. The red is so weakly held that it just sort of floats around anyway. It just doesn't take off.
Is that, are we sort of, with the colour, is that sort of like the different stages of the process then, the different colours?
They're different energetic values, and they're only have those values because of the closeness to the core. The closer to the core, the bluer the color. No.
Yeah, as we mentioned earlier. Yeah, okay.
Right. So, you see blue, how powerful that is? Look at that blue.
Yeah.
And you can see it's a spinner. They spin. These are interference patterns, and they're... this is through a screen, and it's a little strange. I can't really account for some of this, but I do know that they all do the same. They all have the same effect of colors. The green is the same, but not quite like as powerful as the red, the blue, and then the red is really kind of weak looking. And
yeah, it's not focused. I smeared it a little bit.
yeah, well, I could focus it better. Here's a red one too, but it just doesn't have the power. You see this?
Yeah.
It's, you can see it's not really. Look at a blue one compared to these. That's that's on steroids.
Right,
yeah, much brighter. And that, like I say, I can turn on LEDs with the blue, but not with the other colors. Now, this is what happens when you send the light through the Venturi. When that white comes through there, if you focus that white, like right, you see where my cursor is here?
Yeah.
We're going to look at that actually happening when it makes its contact with these fields. You see these round circular fields here?
Yeah, that's what I was looking at earlier, seeing that sort of flat plane on one side. It was like the lateral bits that you showed me earlier, where they start going sideways before.
Here's the deal. Here's with these little bright ones. I'm pointing to it right down here, up here, and up here. Now, the reason they're glowing like that is because they are discs. They were back here. They're everywhere, but they're not being concussed. Now they're being concussed backwards because of the explosion at the Venturi. Anytime you push to shove something, you get white. There's been a huge explosion here, some more over here, some more over here, and some more. This thing is like a gigantic subatomic bomb. It literally is. It's a subatomic nuclear bomb. Now, we're shooting off pieces of light, so this can't hurt you. When they break apart atoms, whole different story. Atoms are like hand grenades. We are just like little cotton balls. We're thrown off like almost nothing. However, all you want, like you could hold a battery in your hand and it's not going to hurt you. Just like this white is not going to hurt you unless you got between a ton of that and ground, and then you're going to be electrocuted.
That's right.
It will force its way through you to get to the dark. We're missing a whole free energy thing here. As far as I'm concerned, I can't see how it could miss.
Well, the strange thing about that is that I'm pretty sure physicists have said that photons are the only thing that don't have an antimatter counterpart. And then all the religious stuff is talking about the light. So you'd think it'd be the obvious thing to be looking at, wouldn't you?
They're so lost. They have no clue what they're looking at all, and they don't want to know. Just like you said, if you could solve the puzzle, there's no more puzzle.
Yeah.
You know? Now, look at this. Look at that. Isn't that a stunner?
Yeah, that's my favorite of all, because you can see the fields.
Look at that.
Yeah.
Every one of those little white streakers, you see them? Zip, zip. And they hit this field, and they're starting to create those fields as they decompress. And what they're doing is they're hitting some black particles. That's the only way they turn into these particles, is by hitting the black particles. And then they turn back into disks. It's a real strange situation, my friend. And this really proves that the black pushes the white. Here it is right here. This one here coming through the Venturi, coming through this way. A little bit of black got through. You see it pushing the white?
Yeah. That I was saying to you earlier, that for me was the picture paints 1,000 words if you put that next to the building.
Yeah, exactly. Because I say, here's the building right here. Okay, here's the building right here. And when this hits it, it burns. It burns. It burns. It burns. It burns. It explodes because the black hits. The black is the only thing that has mass. That white has literally no mass. It's phenomenal that it has so much burning energy. The black is cold. The black is cold, the white is hot. And that's exactly what it is. The white creates heat and energy, and the black creates gravity and cold. If you could measure that black, I can guarantee you it's absolute zero. There is, if you could just look at only the black, that means there's no electrons. That means there's no energy. That means there's zero electrons, is absolute zero electrons. And that's why when you're at absolute zero or extremely cold, it will suck electrons through, called superconductivity. But only for an instant. As soon as you flush all the new electrons in there, it's not superconducting anymore because they're pushing back at each other. You understand?
Yeah. So is this why they started talking gravity waves then? Are they kind of half getting it but not?
I say that again.
Is this because they started talking about, we've detected gravity waves now? Or is that because they kind of half found this but didn't know what it was? Because this is,
it's the stuff I just showed you back here.
Yeah.
When they talk about gravity waves, it's these things that were. Oh, would I knock that off of here? Oh no, here it is, right here. That's these. All the air is magnetic fields.
Yeah.
And when they say gravity waves, the closer you are to the source, the tighter the field is. And it waves out as you go out. And the reason it is because it's so tight that it's really shooting out first. It goes bang, 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 bang. And that's it. It just keeps slowing down. And that's exactly what has happened to the light coming from these stars. Coming from every luminous body, they slow down, and especially where they're in these fields or in these particle clusters. And when you look at the galaxies, that's not empty. That's not empty. That's insanity to think that they can look out there and say, oh, yeah, just keep coming right through there. Oh, yeah, never slow down. No. It's insanity.
Yeah.
So we're living in a total lost reality. I mean, and it's across the board. It doesn't stop here.
Yeah.
But anyway.
Yeah, because it's like you say, nothing stands alone. And I've noticed this through looking at stuff. It's like you have to read, 100 different topics and 20 books on each, or that much information to get. You've got to do the bigger picture, haven't you? You've got to do the bigger picture. It's like a dot-to-dot picture. That's how I look at it. You can't, do you know what I mean? You can't just zoom in on one tiny little piece and then figure out the rest of it. It's like jigsaw. You've got to get as many pieces as possible from many sources as possible. And some of it won't seem relevant until you find out about the other thing that makes it relevant. So that's why Jim Mars used to say he'll consider himself a generalist rather than a specialist. Because they're specialists, they're great for what they're doing, but they're only looking in one direction, aren't they? And there's another, there's a whole bunch, another 359 degrees to look at. So you need generalists as well. Do you know what I mean? We've got to work together. It's just ridiculous.
Yeah. Well, I call myself a material scientist. And I actually had a discussion with a guy today about that I don't like to make claims about things that I have no substantive support for. Because I knew about electron flood theory dipoles for basically my whole life. When I went to college for physics, I told the professor, I said, there's no possible way that this is right. And we ended up really almost having a fist fight by the end of the semester. And I told him, I said, I knew more than he did. I was in Nike Hercules missiles when I was in the Army, and I had just gotten out of the Army, and I went into this stuff, and nobody knew anything about it at that time. This was 1970. So I knew more than he did. I ended up getting an A. He didn't want to give me an A because I kept telling him it's not right. He says, you have to accept it because that's the law. That's that's the law, Einstein's law. You can't go against that law. And I said, no, I can. And what ended up happening is I told him, I said, I want an A. And he said, no. He says, I'm not going to give you an A. I give you a B plus. He says, if you don't accept the reality, I can't give you an A. I said, no, you're going to give me an A. He said, no, I'm not. I said, yes, you are. So I challenged him to figure out the dipole molecular moment of some polar molecule. That I knew there's no way he could do it. I knew how to do it. So I did it, and he says, I showed him my stuff. He says, all right, I give you the A.
Just get out of here.
Yeah, get out of here. I give you the A, get lost. So, and he was such a jerk. And then I knew, and they all were. Same thing happened to me when I got to my duty base in the Army. They tried to pick on me there too, because when I went in, I went in right at the Tet Offensive for Vietnam, and they were losing guys so quick. They were giving everybody rank, and I was in only 7 months, and I made it to E5, which usually take 10 years to do that. So I'm only in there like 6-7 months. It was 7 months. I went in February, right at the Tet Offensive, February '68, and by I think it was October I made E5, and then I got sent to Nike Hercules missile base, and my sergeant was an E7, and he just got E7. He's 16 years in the Army. So I show up there as an E5, and I could see it on his face. Like, they used to call us instant. That's a non-commissioned officer, NCO. They used to call us instant NCOs because it wasn't me special. They didn't have enough guys. They're losing them like crazy. So they would give you rank right away. So anyway, he didn't like that. So he says, all right, Spur. First I show up there. Everybody's drinking coffee. Look like they're having a good time. I go over and grab a cup of coffee. He says, oh, no, hey, Spur, what are you doing? I said, grab a cup of coffee. He said, no. He said, I need you to sweep the floor. I said, all right. So I swept the floor. And now I had rank on everybody except him. But I didn't care. To me, that meant nothing. So I sweep the floor. I get done sweeping the floor. I go over and I grab a cup of coffee. He says, didn't I tell you to sweep the floor? And I said, I did. And he said, yeah, but you swept it from here to there. I said, yeah. He says, now you got to sweep it from there to here. And I said, what are you trying to do there, my friend? You trying to harass me? And he says, yes, and I'm going to harass you to the day you leave. And I said, see you later. I walked out. I went over to the warrant officer. I said, this asshole, and I told him right down the line. He said, what do you want to do? I said, I don't care. He said, go to a motor pool. I said, okay. So I go to a motor pool. They didn't like it either. So I wasn't in any better shape there than I was with him. But he was lost because I was the only trained guy he had. So he goes over begging the warrant officer to let me back. And we worked out a deal, and I never had another problem with him. I did 2 years there.
It must have been so embarrassing for that guy. But
well,
the thing is, it's childish, isn't it?
It was silly. Well, yeah, people get bitter about things. I can understand it to a degree, but and I maybe said some things that I probably shouldn't have said. I'm sort of vocal, and who knows? It didn't work, but it worked out fine. I had a great time after that. He never bothered me again. I did what I was supposed to do, and it worked out perfect.
And the thing is, what you're demonstrating there is one of the most important things on earth, known as integrity. You know what I'm saying?
Well, you got to stand up for yourself.
Yeah. Look at MIT studies. Emotions give off radio waves. Authenticity and integrity is 4 times stronger than love. It's the strongest one. It matters. It matters. And if you're a stand-up guy, it all makes sense now. You're a practical guy, stand-up guy. You've seen stuff. Be vocal. Like I say, if not us, then who? And if not now, then when? We ain't got time to wait around.
You know, I got to be honest with you. When I first found this stuff, and everybody I talked to was just so absolutely negative and treated me like an absolute insane person. I was really the first one talking about this to any degree, openly. And and my family, everybody treated me like, and I said, I don't care. It is what it is, and I'm not gonna back down from it. Sooner or later, but they never did. They never came around. They still haven't come around. And once you confront them early in that, and you stand up for yourself, people just won't stand down.
Yeah, it's a shame, and I think, unfortunately, Roger, I think even though obviously people make their own choices and you can decide how you're going to be, I think unfortunately a lot of it is just straight up brainwashing. We've had so much of it for so long, so many lies, so many. Do you know what I mean? It's like, what's our natural state of being, Roger, as human beings? I don't know. When in history have we not been screwed with? I don't know what we're supposed to be.
Well, never. It's always been a system of domination, but I just don't know. All I can think of about this life at this point, and finding the mud fossils and understanding about space, and everything's biology and space, 100%. You know about that, all the comets and everything?
The dust and the barbecue. I mean, even before I found your stuff, they were saying, oh, space smells of burgers.
Yeah.
Hang on.
Yeah. And I showed you've seen Comet 67P and all the...
And I had no idea they had to make a special scent for the astronauts because they're smelling like barbecues.
Yeah, it smells like a sirloin. You know, well, that's all it is. They're cooking off those bodies in space, and they talked about battles in the heavens, and you know about. Have you seen the Jupiter, the vagina on Jupiter?
Dude, I saw that, right? I saw that, and I thought, you know what? I've been looking at that band of clouds for ages, noticing it smooth on one side and wiggly on the other, and I never thought why. Or do you know what I mean? Some things you just miss them, like the light obviously slows down because it's dark at the bottom of the ocean. Space is obviously full because when you look up at night, what do you see? But you don't put two and two together, do you? Because the premises are being pushed into you in the beginning. I mean, look at the Second World War, right? One household, a man can go to work and it's enough for the household. After the Second World War, they're taxing both the population. Now they've got your kids. It's a trick. It's a trick, bro.
Well, it's domination by people that have things that force you. You know, at this point, all I want to do is have people understand that we're quite likely being controlled somehow, and I don't know how, by the dark forces that were here in the beginning. These things were not mortal. All right. So what does that mean? They live forever. Where are they? What did they say about them? And I read some text the other day, blew my freaking mind. You know how they said they were going to, at this point, I believe 100% that there is a God and there was gods that he controlled, and they ended up, the one that he put in control of the earth, Satan, which was Zeus, ended up coming down with 200 guys and doing all this stuff, having sex with everything. And that's where all these animal-headed things you see carved in the walls all over the place. They have birds' heads and cows with human heads on them, all kinds of things. Yeah. And I believe all of those ancient myths, they are rooted in fact. Now, where the original God came from, nobody will ever know. I doubt even if the original God would know.
There's a statement, because think about it. I mean, I don't know the case of God, but if God's omnipotent and he can know everything, the first thing I'd want to do is find someone like me. If you can't find that and you know everything, you're going to go mad of boredom and loneliness. So you've got to forget yourself, haven't you? Or create a universe
just to see, just to, oh
something
man, I could,
to make
I
new
would,
experiences, aren't you?
I would have such a ball if I was God. I'd do all these same things they did, probably.
Yeah.
You know.
I've read about the Gnostics into that too much, because they said that's exactly, they said this. Obviously, it's just Gnostics. It's the only creation myth that leaves us in charge as well, right? The Gnostics say that Earth is a being. They're saying this. They're saying that in the center of our galaxy, there's these non-corporeal beings that have got so advanced, they ain't got a body, and all they do all day long is run experiments out in the galaxy, right? And one of them had this idea to make a new form, the humanoid form, and they're saying she got sucked into the experiment, right? And that's why you've got the boots forward. It was like the longest lightning bolt ever, and then she messed it up, created a bunch of Archon insect-like things by accident, and then had to turn herself into a planet to let that experiment keep going. Do you know what I'm saying? It's like,
Well, all that's possible, but I go with the ancient texts. Hold on one second. Okay, back again. Now, we're going to go into the mythology a little bit here. Well, a lot. And it all seems to take on a very similar tone. Now, Apollodorus, who I give a credit to for writing about Typhon, and actually so did Hesiod and so did Ovid, but anyway, we'll be talking about them later. But here's the first words from Apollodorus. Now, don't forget, this is book 1, Theogony, all right, 1.1.1. This is the very beginning. The sky was the first who ruled over the whole world, and having wedded the earth, begat the first 100-handed, as they were named. And then it goes on to insanity after that. But what happened was the sky had sex with the earth. Now, how that happened, I can't tell you, but that's what it says. Now, then it goes on about they bore the Cyclopses and all these things, and then the sky bound and cast into Tartarus and Hades, and I mean, all these crazy things, and then all these moons. Iapetus, Tethys, Rhea, Themis, Phoebe, Dione, all of those are moons. And the earth was grieved at the destruction of her children because I guess it was it Kronos? Who's the first one? Sky was the one that was eating all the kids because he was told he was going to be overthrown, and he did. He ended up getting killed by, or no, it was Kronos. The Titans attacked their father and gave Kronos a sickle. All of them except the ocean attacked him, and Kronos cut off his father's genitals and threw him in the sea. This is insanity. But when you go to 1.6.1.3, where you have the War of the Giants and Typhon, that's true. And then you go to Prometheus and Deucalion. You know about this?
I don't, but I'm just thinking, come to think of it, that cutting off the genitals story is actually an African story as well.
It appears to be right straight through all of them. The sky and the earth wedded. Even in Genesis, it says the Spirit of God hung over the waters of the earth or something like that. And it sounded to me like they made it, and that's where life came from. But here's where Prometheus comes in. Prometheus was the guy that made man. This is what they say now. Prometheus molded men out of water and earth. Well, the clay had to be from some other creature. The earth was made out of some corpse. So Prometheus came down here, and out of that corpse, which was earth, he made from water and earth, and he gave them also fire, and he didn't tell Zeus about it. He hid the fire in a stalk of fennel. When Zeus learned of it, he ordered Hephaestus to nail his body to Mount Caucasus, which is in Scythia, a mountain, and Prometheus was nailed and kept bound for many years. Every day an eagle swooped in, devoured the lobes of his liver, which grew back by night. That was the penalty that Prometheus paid for the theft of fire, until Hercules afterwards released him, as we shall show in dealing with Hercules. Now, Prometheus had a son who was Deucalion. You know who Deucalion was?
No.
Noah.
Oh, okay.
So Prometheus' son was Noah. And Noah was a king. And he reigned in the regions of Pythia, and he married Pyrrha. That was his wife. The daughters of Phaestus and Pandora, the first woman fashioned by the gods. Now, when Zeus would destroy the men of the Bronze Age, Deucalion, listen to this, by advice of Prometheus, his father, constructed a chest. Having stored it with provisions, he embarked in it with Pyrrha. But by Zeus, by pouring heavy rain from heaven, flooded the greater part of Greece, so all men were destroyed except a few who fled to the high mountains in the neighborhood. It was then that the mountains in Thessaly parted, and the world outside Isthmus was overwhelmed. And that's when the whole world was saturated. Now, listen to this. Deucalion, who's Noah, floating in the chest over the sea for 9 days and as many nights, drifted to Parnassus, and there, when the rain ceased, he landed and sacrificed to Zeus. Now, then listen to this. This is just unbelievable. So now, Zeus was the god of escape. At that point, they called him. Now, Zeus sent Hermes and allowed him to choose what he would. So he said, Hermes will do whatever you want. And Noah said he chose to get men. He wanted some men. And at the bidding of Zeus, he took up stones and threw them over his head, and the stones which Deucalion threw became men, the stones which Pyrrha threw became women. Hence, people were called, metaphorically, people Laos, a stone. And Deucalion had children with Pyrrha, first Helen, whose father some say was Zeus. Zeus was screwing around with everybody. And then he goes on and on and on. So now, this is just over the top crazy. But apparently, that's what it says even in the Bible. They came down and they painted their faces, all the women, and gave them all kind of jewelry and fancied them up and had sex with them, continuously. And that's what Zeus did. And he was Satan, or he was. It looks like to me.
As good as he'll do until Satan gets it.
Basically the same thing. And he said when the great dragon swept a third of the stars out of the heaven with him down to earth. A third of the stars, there were 600 watchers. A third is 200. And that's what it says in the Bible. Him and 200 guys that signed on with him came down. There's confusion here, but there's also consistency.
So it's like I say, when the other mythologies are saying the same thing, like this is the thing. If it's that crazy, why repeat it? Why does somebody else repeat it? Why does somebody else buy somebody's made-up story and then write it centuries later again?
If I was an academic, I would say, well, obviously you got to revisit that stuff. You can always resell something as crazy as that. Now, if I hadn't found Typhon, or I hadn't found, well, let's look at Typhon just because people may not know who he is. But if I hadn't found the dragon in the desert, which is Typhon, or if I hadn't found the Mudfossils, which are the giants, or I hadn't found Quetzalcoatl, I would never believe any of these things were true. How could you possibly? And
you've done well to see it, because you have to be really zoomed out with your perception, don't you?
Well, you have to be able to see what you see. Here's his little beards. You see the little beards running out of his right down here.
I tell you what gets me on that is when you zoomed in on the feathers.
Oh yeah, here's the feathers up on the top here. You see coming up here? There's one. This one right here is the best one.
I went straight on it, when I seen that, I went straight on Google Maps, I lined it up. I was like, no way. Yeah.
You see, there's one here and one right next to it, and they're all over. But this one has the rib, a really good rib to it. And they have all the way up the East Coast. He goes all the way up the East Coast. This is just his headdress. This is his headdress, and it looks exactly like it does in the glyphs. And he runs all the way up the East Coast, and this is still his feathers up here.
And here's another thing I want to point out as well, because skeptics will say, oh, it's that pareidolia. But then, why is this? You can't keep getting them, can you? Do you know what I mean? There's so many of them.
They can't.
Do you know what I mean?
That's the only thing they can say. They have no ability to respond with any inquisitiveness because immediately they are destroyed of their attitude. Let me show you this. I show this many times, but you can never show a dragon too many times. All right, there's his head. There's his head right there. And this is called the Draco River, or the Dra River, which means dragon.
Yeah.
The Dra River. Now, this is his throat. This grayish spot, right, running all the way down, that's his throat. It's caved in. And over here, these are the scales that would have been outside covering his throat. All this stuff is runoff. You see it's bloody runoff, you see it? It's
it was an affluence.
It's just like mud running out of him. It's just body tissue decaying over the course of time. And now, all of these are dragon scales. This is the line of his body right here. That's his body, right up that line. And each one of these plates are dragon scales, and they have a hinge in them so he can articulate his neck. He can bend it. Otherwise, it'd be he couldn't bend. You see, all the way down.
That's right. And the repeating patterns aren't the repeating and the layered as well.
Yeah.
And if that's just corrosion, then they're not going to be layered and repeating.
No. Anybody that has any ability to think realizes what they're looking at. You can't not realize it. No.
I think this is the trick. You've just got to suspend your disbelief and go and look.
Let your mind wander. Let your mind think. Now, the ancient texts say he was cut in his throat, which is Zeus used his great and mighty sword, which they say is thunderbolts, and cut right across his throat. You see this? And that is cut. And this right here is red blood running out, and that's why this is solid green. Green is what happens because of nitrogen in blood and all of the transition metals. It creates absolutely fabulous growing conditions. And this is in the middle of the desert. And look what's growing here.
Yeah, and you pointed that out to your buddy, I can't remember his name, and you was, why is the green in the desert? So I zoomed in, that's a tourist spot. It's that water, why just there? Do you know what I'm saying? And if you notice it, the green starts to fade away. Do you know what I'm saying?
Right. Now, you could see the blood has all run out here. And the same thing down here, there's all kinds of plants and things growing. See it? Growing in the blood. They love blood. They love blood.
Yeah. Yeah, I've got a garden allotment plot. Blood meal. Feather meal.
Blood meal. Blood and feather meal. Both, they work the same. They claim it's because of the nitrogen. I think it's got to do a lot more with the transition metals, but because blood is saturated with transition metals. Anyway, it comes down through his whole body, which runs all the way down across to his scales down here. Still in his tail are some more scales. Now they're plated. And I have a dragon scale here. It's built basically the same. It's a small one. But you see them?
That's how it helps. I see it, and that's how it helped me make the leap with a lot of this stuff. that hair follicle.
Oh,
That's
yeah.
undeniable.
Yeah,
That's
yeah.
undeniable.
I know.
Once
Yeah.
you've made that leap, it's like, well, sky's the limit, literally.
Yeah, yeah. I got so much stuff. My area here is just saturated with it. Anyway, and then they're all living where he poops too, because that's where it's very fertile, right over here. This is the poop.
Yeah, and that's what that's where the fertility is. It's where you're going to live, isn't it?
Well, wherever there's fertility. The same thing with the Tigris and Euphrates. That's nothing more than a digestive system. Just like this. And the poop runs out this side and the urinish stuff here, and then it mixes together and then it lands on your windshield as a bird poop.
Yeah, and this other thing as well about you talking about the eyes to notice things. But I haven't done biology since like school, but I've got a good memory, right? And so biology looks weird. No, you don't get to see inside your body, do you? Do you know what I'm saying? So unless you look at biology pictures, you don't know what the insides look like. So you wouldn't recognize it, would you?
Yeah, well, I work with a guy who does autopsies, and way back when I contacted him about the fascia. You ever hear me talk about the fascia?
Yeah.
And I said, well, what is this stuff? And he says, oh, it's just fuzz. It doesn't do anything in the body. It's like a cushion. And I said, I don't know. I said, well, let's look at it. We looked at it, and he realized, no, that's not true. And then, about 8 years later or so, they published a paper how it was a fluid-filled highway, and that's where all these enzymes and bacteria live.
Yeah.
And that's
just going to change medicine, I think.
It should. Oh, it absolutely should. Without the enzymes, you're screwed. But anyway, here's Typhon. So here's his whole body. Now, he is attacking this gigantic fish. Now, I cannot account for the sizes. All I can say is I am a material scientist. If there's something material here, I point it out, and this is a fish. Now, Typhon tried to kill him, quite obviously, because this is what he spit. And it comes out of his beards. You see the beards coming right here, one here and one here out of his face? You see him?
Oh, yeah. Yes.
All right, you see this one?
A bunch of these videos as well. Yeah. It's like I say, it's nasty stuff. That's what you said. It's nasty stuff, right?
I don't know what it
makes you
is.
say that?
It would be interesting to see what the chemistry is, but it doesn't look inviting. Let's put it that way. And it came down and combusted literally on that fish. All of this is that stuff. And it is. Look at it. It's just, you don't see.
It's crazy stuff. It's crazy. I'm trying to let's try and make that run off with water and dust. I don't know. It looks too detailed to me.
Where do you see?
How
Where do you see?
What little streams do you need?
Yeah, right. Now we know it's coming down, attacking the fish. It's all coming down here. Look at it. It's just as noxious as can be. Now, what happened here? It's hitting something here. Where are we? We're just above the fish's fin.
That's like the impact point then.
It's something. It's starting to impact into him. Now wait till you see what happens. So the fin doesn't have a whole lot of biology to it. So don't forget now. Here's the fish. We're coming all the way up around here. His tail is halfway buried.
Mm-hmm.
I believe that's his eye. This here, I don't know what it is. He could be eating a squid or something. I don't know. But
I thought it was because it looks like there's a squid underneath it.
Yeah. But what you see here is the scales. These things here are the scales. Now up here.
I checked that out as well just the other day. They have got the same shape, haven't they?
Yeah. Now here's the hump.
Fish's scales.
This is the hump on his back.